Hi everyone, welcome back to this Unity tutorial series on how to create a roguelike like Vampire Survivors. So as you all know in Vampire Survivors, every level map is infinitely generated in some way. What that means is that if you continuously travel in a certain direction, you will not loop around nor will you hit a roadblock, you will simply travel forever. So in this part 2, as the title of the video suggests, we will be tackling exactly that. And by the end of this part, you should have something like this, which is map generation, and we will have it optimized as well. And without further ado, let's begin. Before we can get started with any code for our map, we first have to set up our terrain. We'll begin with the background. We'll be using the LPC terrain repack that I found on OpenGameArt as our terrain sprite sheet. You can find the link to this in the description below. It contains a variety of terrain tiles and props which will be helpful in populating our map later on. After extracting the folder, drag and drop this into the art folder and rename it to terrain spreadsheet. Once that's done, the next thing we have to do is to slice the spreadsheet. Similar to how we sliced the player spreadsheet in the previous part, we first have to change a couple of settings in the inspector window. And now we gotta change the sprite mode to multiple, change the pixels per unit to 32, change the filter mode to point no filter. And after making sure your settings is the same as mine here, scroll down and hit apply to confirm the changes. Now let's head into the sprite editor by clicking on the button in the inspector window. For now, we only want to slice out a few of the terrains, which is these three, 1, 2, and 3. Now, here's where things start to differ from the player spreadsheet. If you recall previously, we had used the automatic slice option located within the slice pop-up here at the top left of the sprite editor. However, because all the sprites in our terrain spreadsheet are of different sizes, you can see some are big, some are small, it's better to manually slice them. To do so, hold left click and drag anywhere on the sprite editor, and release when you have your desired slice, or the size of your slice, sorry. You should now be able to see a blue box with green coordinate points. Don't worry if the box is too big or small, you can always resize it by dragging the 4 blue dots at the corner of the box. Alternatively, you can also use the pop-up menu that comes with creating a menu slice located at the bottom right of the corner to achieve maximum precision. Yeah, let's use the latter, so we use this box here. Now all we have to do is to resize our slice to be the exact same as the desired terrain tiles. We can begin with this, number 1, and just follow my position values as shown, which is we're going to be using 0 for this, 352 for the Y, 32, 32. And now for number 2 will be 32, 352 same, 32, 32. And now position X, 64. And now Y, 352, 32, 32. Okay, done. Now hit apply at the top right to confirm the changes once all 3 terrain tiles have been sliced out. And now we can close out the sprite editor and head back to your editor. In your project window, you should be able to see these sliced sprites. Let's now create a background for our terrain. To accomplish this, you'll be using a tile map. When working in pixel art, I recommend to use tile maps when stylizing your environments as they can be beneficial in many ways. Brackies has an amazing video explaining tile maps and their benefits. So let's head into the hierarchy and then create a rectangular tile map. You should now be able to see a grid within your scene view when you select the tile map itself, and rename the grid in your hierarchy to be background grid and the tile map to be a background tile map. It's always good to stay organized like this. But before we can get started with painting our tile map, we first have to create a tile palette. Navigate to the art folder and create a folder called tile palettes. You'll use this to store any future tile palettes. Now there are 2 main ways to bring up the tile palette window. The first of which is just to click this button here, and the second of which is to go up here, window, editor, 2D, then tile palette. If you don't have this button, it may be because you're using an earlier Unity editor version. Alright, now after your tile map window is open, drag and dock it however you like until you're satisfied. And afterwards, let's click and create a new tile palette at the top of the window here, and it should bring up a pop-up. Now change the name of the palette to be background tiles and make sure the grid and cell size is set to rectangular and automatic respectively, if they aren't already. And once all the correct settings are in place, simply click create. Your Explorer should now show up And all we have to do is navigate to our tile palettes folder that we created previously and select it. Before we can proceed further, however, let's head into our tile palettes folder and create a subfolder called tiles to store our tile assets. Multi-select all the slice sprites before dragging and dropping them into the tile palette window and navigate to the tile subfolder within the tile palettes folder and select it. Alright, great. Let's begin painting our tile map. Simply click on any of the tiles within the tile palette window and head into the scene view. To place the tiles, all you have to do is left click on the desired cell. And there's a faster way of doing so. You can click and drag to paint multiple cells in a short time instead of just clicking each of them individually. And yeah, let's make sure to paint until our entire game view has been filled with tiles and even more. For example, I'll paint mine with a 2020 grid size so that it is big enough. Make sure to choose a good mixture of the 3 tiles so they don't seem repetitive. Alright, now you can hit the play button, and as you can see, the entire game view should be filled up. And if it's not filled up, it's probably because your player is not reset to the 0, 0 position, so just reset it, as it will be very important later on. While painting, you might notice some common tile map problems. If you did not encounter any of the following problems, you may proceed to the next section. So the first problem is the gaps in between the tiles, and the second will be the lines. Now, for the gaps in between the tiles, like shown here, it usually means that the sizing of the tiles are not uniform at all. Double check the sizing of the tiles given, which is 32 by 32, and make sure they are the same before proceeding. You'll find that the gaps will disappear after inputting the correct settings. As for the lines, the problem usually stems from anti-aliasing being enabled. Navigate to Project Settings and hit under Quality, and now under the anti-aliasing dropdown, set it to be disabled. And you should now see that the lines have disappeared. Now it's time for us to create our first chunk. By definition, a chunk is to divide data into separate sections. You've probably heard of the word from Minecraft or other sandbox games where they define a segment of the world. That's the exact kind of concept we are aiming for. These chunks we will be creating will be used to not only define the background but the props that are around the world, which includes trees, rocks, and future power-ups. Create an empty game object and rename it to terrain chunk. Make sure to also reset its transform as it is very important. You can do so by clicking on the 3 dots over here and just hitting reset. Next, we also want to drag our background grid onto the terrain chunk and make it a child. And let's create another empty game object under the terrain chunk and name it props to hold all our props. This will be used to store any background elements that the player will come across. Let's also reset its transform. Now with that being said, let's create an empty game object with the name prop location 1 under props and give it an icon by clicking on the blue icon, clicking on the cube icon next to the name. I'll give mine a yellow icon. Make sure to reset the transform of this object as well and move it to anywhere within the bounds of the tile map. If you can't really see the icon, it might be because your gizmos at the top of the editor is disabled, so you can click this button to just enable it. Now, let's create several more prop locations and do the same until the entire chunk has been populated enough. Make sure to space them out nicely such that no 2 prop locations are right next to each other. Okay. Now, as you might have guessed already, the reason why we are creating these empty game objects instead of simply putting their props themselves in these locations is because we want them to be random, so that these will be the spawn points of the randomly chosen props. This is so that every single game feels different and it is effective in boosting replayability. We can now finally head into some code. Create a script called prop randomizer inside the scripts folder and add it onto the terrain chunk. Let's open it, and we want to start by creating a few things. First off, we need 2 game object lists called prop spawn points and prop prefabs, used to reference the prop locations and the prefabs of the props respectively. Now we want to create a function called spawn props, and then inside this function we want to create a for each loop referencing the prop spawn points. Let's also create an int within the for each loop called rand and set it to be a random number that has the value of 0 and the amount of objects in the prop prefabs. We're going to use this to select the random prop that we're trying to spawn, or that we are going to spawn, sorry. Now let's instantiate the random prop prefabs at the current position of the prop spawn points we are looping through and set it to have no rotation when spawned. So we're going to be using quaternion identity. Now all that's left to do is to call the spawn props function on the start function. Now head back into the editor and go to your terrain sprite sheet. We now want to open up the sprite editor and begin slicing some props for our use. I'll be specifically using the props at the bottom right, but you can choose any that you like. Most of the slice sizes are 32 by 32, but you can manually adjust the ones that are bigger. Alright, now that's done, we are going to have to drag and drop each of the sprites that we just sliced onto the scene, and then multi-select all of them and reset their transform. We are then going to want to create a subfolder under the prefabs folder and call it props, and drag and drop all of the sprite game objects into the props folder to make them a prefab. Next, let's delete all these existing prop game objects on the scene as we no longer need them. Let's now drag and drop the prop locations and the prop prefabs into their respective views. And to make it easier while dragging and dropping multiple items into the inspector views, let's simply lock the inspector over here. So this makes it such that it won't change when clicking on another item. Just remember to unlock it once you're done. And then let's just drag it in, and yep. Now when you hit play, you'll be able to see that the random props spawn at the prop locations. Although this is great, there is one thing that we have to do before moving on. If you look towards your hierarchy, once the props have spawned, you should be able to see that each prop spawns outside of the terrain chunk. What we want instead is for the props to be spawned as children of their respective prop location. This will help when we optimize in the future, and it's also good for keeping organized. Now head back into the prop randomizer script, and now we have to do two things. Let's assign a game object to the newly spawned prop, and reference the game object's parent and set it to the current spawn points transform. And now when you hit play, the spawn prop should be parented to the locations they spawned at. Alright, awesome. Now we'll create a way to spawn more chunks, such that whenever a player is about to move off a chunk, another chunk spawns, thus making the world infinite and random. Create a new C# script called map controller and open it up. Inside here, let's create a few variables. The first of which will be a public game object list called terrain chunks, used to store the prefabs of the different terrain chunks. Secondly, will be a public game object called player, used to reference the position of our player. The third will be a public float called checker radius. You'll see why this is handy later on. Number 4 will be a vector 3 called no terrain position, used to determine the next position where there isn't a chunk. Number 5 will be a layer mask called terrain mask, used to track which layer is the terrain and isn't the terrain. And last but not least, number 6 will be a player movement called PM, used as a reference to access variables. Let's also create a function called chunk checker and call it within the update function. This is where we'll be doing the checking to see if we should spawn another chunk. Head towards the chunk checker function, and inside there we want to start by checking the direction in which the player is moving. Let's begin by creating an if statement. Now this statement will be used to check if the player is moving right while not moving up or down. To do so, we simply have to check the mover vector within our player movement like so. Now, within this if statement, we're going to create another if statement such that it will be a nested if statement. This time, the condition will make use of the physics2d.overlap circle function to check if whether or not there is a chunk a distance away from our player. This is because we don't want to spawn chunks continuously, but only the areas that just don't have a chunk. The distance in this case will be the length of our tilemap that we created previously. As mine is a 2020 square tilemap, the distance is naturally 20. And of course, we are also moving right on the x-axis while not moving on the y-axis. So since that's the case, the distance of the point to check from the player would be new vector 3, 20, 0, 0. The other parameters we need to have to use the physics2d.overlap circle is the radius and layer mask, both of which we created as variables recently. That's why I said that it'll be useful. Now, we must also put a not operator at the front of the condition because we are only trying to spawn a chunk if there isn't any chunks on that specific point that we overlapped. Inside of the if statement, let's do a couple of things. Set the no terrain position to be equal to our point parameter that we use for the if statement. And create a new function called spawn chunk. Now, within the spawn chunk function, we just have to choose a random chunk and spawn it. Very similar to how we did for the prop randomizer. Make sure to call the spawn chunk function after setting the no terrain position. Now comes the tedious part. As you might have guessed already, we have to do this for not only the 4 cardinal directions, but all directions the player can move in. Meaning, we have to do it for right, left, up, down, right up, right down, left up, and left down. The difference to look out for will be the point at which to check. Similar to how we counted the length of the tilemap using the cells, up and down uses the count of the width of the tilemap. The width of my tilemap is obviously 20. Now, when all is said and done, you should have something like this. Alright, great. Now head back into the editor and create a new empty game object called map controller. Make sure to attach the script to it as well. Next, create a new layer by clicking on any game object and clicking on the layer dropdown under its name, and selecting layer. Add a new layer called terrain at whichever layer you want to use. I'll be using the user layer 6. Select your terrain chunk and change its layer to be terrain, and make sure to change the children as well because we want all children to be a part of the terrain layer. We also need to add a box collider 2D and set it to be a trigger, and the size should be the same as our tile map, so it'll be 2020. We need this because physics2d.overlap circle requires a collider and it will not work without a collider. Let's now create more chunks for variety. But before that, let's create a prefab of our current terrain chunk. Create a new subfolder under the prefabs folder and name it chunks. Then drag the terrain chunk into the folder. You can leave the terrain chunk in the scene view as it will be our starting chunk. Now, with the terrain chunk in the project window, simply Ctrl D to duplicate the terrain chunk. I'll just do this twice so that we have 3 different terrain chunks, and configure the amount of prop locations you want and their positions within each of the terrain chunks. All we have to do now is to fill in the map controller parameters. Drag and drop all terrain chunk prefabs into the terrain chunks parameter. Drag and drop the player into the player parameter. Set the tracker radius to something small like 0.2 and set the terrain mass to be terrain. Now hit play and you should be able to see the chunks forming around you when you move. Awesome. But as you can tell, there are a couple of problems with this. The first and most noticeable problem is the gaps in between. As you can see when I move around, there's a lot of gaps. Although we are using a fixed distance, this is happening because we are referencing the player position which is constantly moving and constantly changing. As such, there will definitely be some gaps in between the terrain chunks. The second issue would be that some of the chunks are overlapping, and the reason for that is the same as why the gaps are happening. Before we begin making any improvements, we first have to understand what we are trying to achieve. So in layman terms, we are basically just trying to create static points of reference for every direction the player can move in, which is the 8 directions that I previously mentioned. So these static points will be attached to the terrain chunk itself and will be the point of reference for spawning the next chunk. Okay, now open up the terrain chunk prefab and create an empty game object under it called right. Now this will be used as a point to determine where to spawn the chunk on the right of this chunk, if there isn't a chunk on the right. Okay, so make sure to reset its transform and set the X position to be 20, or whatever the length of your map is. We are doing this because if you duplicate this terrain chunk and place it at the exact same location as you can see here, you'll see that they align exactly. Make sure to also give it an icon so you can see it without having to select it. Okay, so do the same for the other 7 positions. So for right, we just did it. It was position X20 and Y0. So for left, it will be -20 and Y0. Up will be 0, 20. Down will be 0, -20. Right up will be 20 and 20. Right down will be 20 and -20. Left up will be -20 and 20. And left down will be -20 and -20. So once you are done, copy the static points by multi-selecting all of them and heading over to the other chunks you have created. Okay, now we have to create a way to reference what chunk the player is standing on. This is because these static points are sitting on the chunk and we need to reference them to spawn the next chunk. So head over to our map controller first and create a new variable called terrain chunk. Then we simply want to return at the top of the chunk checker function when there isn't a terrain chunk. This is a failsafe basically. Okay, now create a new C# script and call it chunk trigger. Inside here, we want to create a reference to the current chunk that we just created in the map controller. And also let's create a public game object called target chunk used to change the current chunk. And also let's set the current chunk to be the target chunk if the player is within the boundaries of the chunk area, meaning within the collider. And also let's set the current chunk to be null if the player exits the chunk area. Alright, so now head back into the editor and set the player's object tag to player. Once that's done, open up your terrain chunk again and create a new empty game object called trigger. Make sure to reset its transform as well. Now add the chunk trigger script onto the object and drag the terrain itself into the target map. Then add a box collider 2D to set it bigger. Set the size to be the size of the grid you painted with a little margin. Now this is very important because this little margin can help us a lot. So in my case, since mine is a 2020 grid, I'll just go with 18 by 18. So the reason why we need it to be smaller than the actual grid we have painted is because we need space and leeway for the on-trigger exit 2D to run. This is also the reason why we're creating a new game object and putting the trigger and script on top of it. We want to be able to change the size of the collider in the unlikely event that the player walks back and forth of the chunk. Yeah, so just to make sure that nothing funky will happen when they do that. If we simply place this on the terrain chunk itself, it won't work because the on trigger will only detect the first collider and it will interfere with our map controller script that is already on the terrain chunk script. So let's copy this over and yeah, so do the same for the other chunks that you've created. Okay, now open up your map controller script once again, and now we can start referencing the static points. Similar to how we set the no terrain position to be the player position plus length slash width of the tilemap in their respective axes, we can do the same for the static points while omitting the player position for maximum precision. Now, change the setting of the no terrain position and the condition of the if statements to be their respective static points. We can do that by simply referencing the transform of the needed point with its name by using the transform.find function. Now when you hit play, you can see that these chunks spawn perfectly and are aligned with one another. Awesome. Okay, so before we end off this part, there's something very important we need to do, and that is optimization. Since this game is infinitely generated, there will definitely be heavy load due to the amount of chunks we are spawning, especially in the later parts of the game. Therefore, we must create a way to minimize the amount of load. So our goal for this optimization will be to remove the chunks that the player is far away from. However, since we can't just outright destroy the objects, since they have to still be the same chunks when the player eventually walks back, we should just disable them. So let's start by creating a few things. So let's go and create a game object list called spawn chunks that we will use to store the current chunks. Then we need a game object called latest chunk used to reference the last chunk that we just spawned, and a public float called max op distance, which is just a short form for maximum optimization distance, used to set our max distance for each of the chunks from our player before we disable it. And then the fourth is just create a float called op distance used to reference the current distance for each of our chunks from our player. You'll see why this is useful later. Next up, we just have to set the latest chunk to be the instantiated game object inside spawn chunk, and then we need to add it to the spawn chunks list. Alright, now we are done with the setup. Time to now create the optimization. Create a new function called chunk optimizer and create a for each loop inside it with the spawn chunk list as the condition. Inside here, we simply have to set the opdist to be the distance between the player and the chunk we are checking by using the vector3.distance function. Afterwards, we just need to check if it is more than the max opdist that we will set in the inspector later on. And if it is, let's just disable this object, and if it's not, we can just keep it enabled. Make sure to call the function inside update as well. Now head back into the editor and set the max opdist parameter in the inspector. I'll set mine to 50. Now, take note that it must be greater than both the length and the width of the tile map. This is because a lesser value of this max op this will cause the map controller to spawn another chunk over the existing one because it will still be disabled. So this is very, very important because the collider doesn't work when it's disabled. So the physics 2D overlap circle cannot detect it. Now, if you hit play and continuously move towards the left or right, after a while, you should see that the furthest chunk will disable itself and if you walk back, it will return. However, as you can see, the original block doesn't disappear, and this is because it is not present in the list. We can just leave it as it is because it won't cause us trouble. But if you like, you can just add this like original chunk onto that list first. Okay, so before we end off, let's also add a cooldown to this optimization since we don't want to be continuously checking for the distance as the calculation uses up a lot of processing power because we are basically just continuously just checking for where each of these chunks are. And the more we spawn, the more load it will have. So let's create a new public float called optimizer cooldown and another float called optimizer cooldown duration. And then all we need to do is just create a countdown loop like so. Okay, now let's head back into the editor and set the optimizer cooldown duration to be something like 1. Great, now instead of calling every single frame, our optimizer now calls every single second. This will definitely be of help in the future. That's all for this part. In this part, we went through how to create infinite map generation. If you are a patron supporter, you can download the project files for what we've done so far in the description below. So that's all. I'll see you guys in the next part. Bye.